Now the concept is static algorithm, that is otherwise known as flooding. The flooding is mainly based on the every incoming packet is sent out, except that one is arrived on. For every arrival, there is a sending out of the incoming packet. So major advantages of generating vast number of duplicate packets of data. So there is a damping process is done, but the measurement is to be here. The hope counter is to be measured here with the header of the each packet. Here the header of the each packet to be measured. So when the counter reaches the zero, the particular hope discarded all the packets. So this is the main thing here. It is to measure the length of the path from the source to the destination by using by measuring the hope counter. The particular length of the path from the source to destination is calculated. This is a process in flooding, that is static algorithm. The next one is distance vector routing. In distance vector routing, that maintain a router table for maintaining the distance between the nodes. So there you can see a diagram here: A, B, C, D, E, F, G, H, I, J, K, L. This is one of the subnet here. This distance vector algorithm is otherwise known as Bellman-Ford algorithm, that is routing algorithm, or Ford-Pulgerson algorithm. This comes for your one word. Next, you can see the diagram should be divided as a four columns. That is the delay storage. Delay storage. Then, when there is a transmission of A to A, there is no delay, so it is mentioned as zero. Then, when there is a transmission between B to A, there is 12 delay. Likewise, four delay transmissions should be stored in the routing table. By using this, we can calculate the delay from one node to another. So in distance vector algorithm, the main thing is storing the distance, that is knowing the distance to the each destination. Then this is one example for distance vector algorithm. This is the example: A, B, C, D, E, F, G is the graph here. It mentioning the weight here. You can see a tabular column. A to A there is no distance. Then A to B, that is A to B, there is one distance. Then A to C there is one, and A to D there are infinite routes are there. So it is mentioned as infinite. Then A to E there is one, then A to F there is one, and A to G there is a multiple path there. So likewise, the every node should be one node should be mentioned, and there is displaying the distance to reach the each node. So this is a simple example for the distance vector algorithm. Then here you can see the another example to be here. This is also mentioned with some example. Then the main thing is here the distance, cost, and next hope should be that is destination, cost, and next hope to be stored. Um, by following table, you can identify that this is the destination, this is the host, and the next hope. When there is A to A, there is a cost is 1. So when there is a C to another, that is the routing table maintained at the node B. You can see here B to A. Okay, B to A, B to A. So B to A there is a cost 1. The next hop is A. What is next hop? So B to A, the next hop is A, and then here B to C 1. This you can see that B to E. Here you can easily identify B to E. The cost is 2. Okay, B to E. So B to E there is a cost is 2. 1 plus 1. The next hop is A. So the where it is travel, that is mentioned in the next hoop. Then B to G. So you can